Hey mathematicians, every one of these problems can be solved by entering the equation into Desmos and seeing where the two graphs intersect, so where your solution is. But the first part is that we got to get an equation to put into Desmos, right? So for problem number 1, pause the video, read the word problem, make sure you understand some keywords that you probably want to pay attention to. Make sure you know what a dining hall is. Make sure you understand what they mean by saying that the tables are occupied. So pause the video, read the problem, define any words that you don't know, ask any questions, and then restart the video once you are ready to turn it into an equation. All right, mathematicians. So the first thing I notice is that it tells me that this is a situation that involves two constraints. And I want to make sure we remember what a constraint means. So a constraint is a limit. Frequently, you also see it represented by some kind of a total in the problem also. So I'm going to look and see where I see some limits or some totals here. And again, the problem tells me that there's going to be two of them. So the first thing that's jumping out at me is that the dining hall has a total of 25 tables. So that is going to be one constraint or limit or total. And the other one is kind of hidden in disguise here. So it says, on a busy evening, all 190 seats at the tables are occupied. So that means that out of the 190 seats, there is somebody sitting. That's what we mean by occupied. There is somebody sitting in every seat. Now, we're going to assume that everybody sitting in a seat is a person. Nobody's got their dog sitting in an empty seat or anything like that. So that means that there must be a total of 190 people if all the seats are occupied. So those are our two limits, our two constraints, our two totals. So now we need an equation to represent each of these constraints. So I'm going to focus on my first constraint first, which is my total number of tables. And I can see in the problem, it's asking how many long tables, and it says that long tables are going to be equal to X. And how many round tables, and we're using Y to represent round tables. So that means our total of 25 tables is equal to the number of long tables plus the number of round tables. So the first equation that represents our first constraint is going to be, sorry, it was bugging me that I didn't write that quite right, is going to be 25 equals X plus Y. Now let's go back and look at constraint number 2, that we had a total of 190 people. And revisiting my problem, I can see that long tables can seat 8 people. So that means that I'm going to use 8x to represent the number of people that are sitting at the long tables, because 8 people can sit at each long table. So that means 8 times x. And then round tables can seat 6 people. So that means that I need to do 6 times y to represent my number of round tables. So my second equation is going to be 190 equals 8x plus 6y. So now that I have my two equations, so 25 equals x plus y, and 190 equals 8x plus 6y. Whenever you have more than one equation at the same time, this is what we call a system of equations. So you are going to type both of those equations into the Desmos calculator, see where they intersect, and that will tell you your values for x and y. Hey, for problem number 2, how about you pause the video and take a look at the word problem and see if you can figure out what are the two constraints? What are the two totals that you see here in the problem? And then restart the video when you're ready to check. Hopefully you really did pause the video and now you're ready to check. So I noticed here that a family bought a total of 16 adult and child tickets. So one of the constraints is that they bought a total of 16 tickets. So that is one limit, one total. And then I also noticed that they paid a total of $141. So they spent a total of $141. So those are my two constraints. Now I've gone ahead and labeled my two different quantities that I have in this particular situation. And it says that so I've got a total of 16 tickets. And I've bought adult tickets and child tickets. So that means that my number of adult tickets, and the problem tells us to use A for adult tickets, and it told us to use C for child tickets. So if I add my number of adult tickets plus my number of child tickets, that will get me a total of 16. So that's one of my two equations. Now I can see my next limit has to do with money. So let's see where I see some information about money. And it says adult tickets are $10.50 each. So that means I do $10.50 times my number of adult tickets. So 1050 times A. And then my child tickets are $7.50 each. So that'll be $7.50 times C. So if we take our amount of money that we spent on adult tickets plus our amount of money we spent on child tickets, it's all going to equal $141. So our two equations for this situation are 16 equals A plus C, and then 141 is equal to 1050A plus 750C. Now the only issue here is that the Desmos calculator doesn't understand variables except for x and y, because x and y are the two axes on the graph. So when you go to type in the equation into Desmos, use x for A and y for C. So when you go to actually put them in here, what you're going to want to type is 16 equals x plus y, and then 141 equals 10.50x plus $7.50y. So then once you type those in there into the calculator, you will be able to see where they intersect and you will get your solution.